Hello everyone, myself Hans. Today we are going to solve the problem of integral calculus from topic beta and gamma function. Here in the question, prove that integral is given by 0 to 1 x and log 1 by x power m dx. Then we have to prove gamma m plus 1 is equal to n plus 1 e power m plus 1. Let's solve the problem. Given integral is this is given by I is equal to integral limit is 0 to 1 x की power n and log 1 by x की power m dx. Let log 1 by x is equal to y, and we can also write this is that is log of once again x to the power of minus 1 is equal to y, and using the property of log, that is minus of log x is equal to y, and from here this is log x is equal to minus of y, and we can also write that is x is equal to e to the power of minus y. On differentiating both the side with respect to x, this is given by dx is equal to e to the power of minus e to the power y dy, and we can also change the limit. This is given by when x is equal to 0, when we have to put x is equal to 0, we get y is equal to infinity, and when we have to put x is equal to 1, we get y is equal to 0. So we can put the limit in the given integral, and we can also put this is equal to I. Integral limit is changed. Here is limit is infinity to 0 and x power n. Here the value of x is e to the power of y, e to the power of minus y, e to the power minus y power n, and we have to let log 1 by x is y, so we can write y e power mn. In place of dx we can also put minus of e to power minus of y dy, and further we have to solve. I is equal to minus is taken into outside. This is integral limit is infinity to 0, and e to the power of minus yn, and into here e to the power of minus y, and into y की power m dy, and further we have to add. We can also change the limit when we have to remove the minus sign. This is given by I is equal to integral limit is 0 to infinity, and from here e to the power of, the base are same, when we are power are adding, this is given by minus y and minus of y, and this is y की power m dy, and further we can also write this is given by integral limit is 0 to infinity, and from here we have to take minus of y is taking common. This is minus of y is taking common, and this is given by n plus of 1 and ym, this is dy, and we can also let here, that is let y n plus of 1 is equal to t, and we can also let this is y n plus 1 is equal to x. Depend upon you either let x, or if t, we can let t is better. Further we have to differentiate both the side. This is given by dy n plus of 1 is equal to dt, and we have to put the value of dy. This is given by dy is equal to dt upon n plus of 1, and we have to change also limit. When we have to put x is equal to 0, we get t is equal to 0. When we have to put t is equal to infinity, y is equal to infinity, we get t is equal to infinity. So limit is nothing to change, and further we have to put here, we can also y is equal to t upon n plus of 1, and further we have to put the value here. This is given by I is equal to integral limit is 0 to infinity, and here e to the power minus of y n plus 1. We have to let y n plus 1 is equal to t, so we can write e to the power of minus t, and in place of y to the power m we have to put the value of y is t upon n plus 1 the whole power m, and we can also put the value of dy. This is dy is given by dt upon n plus of 1, and further we have to solve. This is also given by integral limit is 0 to infinity, and from here e to the power of minus t, and here is t की power m upon n plus 1 की power m, and here is dt upon n plus 1 is already present, and further we have to n plus of 1 की power m and into n plus of 1 we have to take outside. We get 1 upon of n plus of 1 की power m plus of 1. Here the base are same, so we have to add power, and the integral limit is 0 to infinity, and this is given by e to the power of minus t and tm dt. Further we have to change the given integral into the gamma function form. This is given by I is equal to 1 upon of n plus of 1 की power m plus of 1, and integral limit is 0 to infinity and e to the power of minus t, and we can also write t की power m in the form of that is t m plus of 1 minus of 1. This is dt, and comparing the gamma function formula, this is given by gamma n is equal to 0 to infinity e to the power of minus t n minus 1 dt, and this is given by here e to the power minus t m plus of t n minus 1 dt. So we can also write this is I is equal to 1 upon of n plus of 1 की power m plus of 1, and this is written as gamma m plus of 1. Using the following formula we can also write gamma m plus 1, and this is given by which I proved gamma m plus 1 upon n plus 1 की power m plus 1, and we can also write this is given by gamma m plus 1 upon n plus 1 की power m plus 1. This is the required solution of the given problem. Thank you class, and thank you for watching. This is a 10 mark question.